Hi everybody. Today we're going to talk about the formulas and names of ionic compounds, part 1. We're going to start with binary ionic compounds. Binary means that a compound will contain two different elements. Think of bi means two, like a bicycle. Formulas for binary ionic compounds must be neutral. This means that the amount of positives has to be equal to the amount of negatives within the compound. And last, the formulas are determined from the charges of the various ions within the compound. All right, here is that periodic table yet again. So we will be looking at binary ionic compounds, and that will consist of elements that are in group 1, group 2, and group 3, but on this side of the staircase. So starting with aluminum and then working its way down. Okay. You might also see a couple of these in group 14 here as well, or the other ones underneath 15. So basically these are pretty consistent within what we'll be using for metals. Remember, this side is found where the metals are found. Okay, on this side of the staircase, remember those are the nonmetals, and nonmetals are negatively charged. We're going to start with finding the charges of the positives first. Okay, we're going to start by doing an example between lithium, and we'll start with chlorine. Okay, so if you take a look at the periodic table over here, all right, lithium, you should be able to find it pretty easily. It's right here. Okay, it's in column 1, so that means it has a +1 charge. Okay, so I'm going to write the plus. You can write +1, but we write plus. Chlorine is the negative. That is found over here. You'll be able to see it right over there. It's number 17. That is in column 17, so that has a -1 charge. Okay, now if you're wondering how I found that charge, it's real simple. This column here, let me go ahead and circle it. This column here has a -1 charge. This column here has a -2. You notice we're just counting backwards from the noble gases, because the noble gases have a 0 charge. They don't have any charge at all. They're neutral. So the -1 column is group 17, the -2. If you keep going, what do you think nitrogen is going to be? If you said -3, you're correct. And then this would be -4 if we went that far over to carbon and silicon. Remember, the negatives are only the nonmetals on the right side of that staircase. When looking at the periodic table for the positive charges, we're doing the exact same thing, but instead of starting from the right side and working left, we're going to work from the left side and work right. So this whole column has a +1 charge. This whole column has a +2 charge. Then if we look at column 13, aluminum and below have a +3 charge. And then same thing with germanium over here, number 32, that has a +4 charge because that's in group 14. So hopefully you can kind of see the pattern of how the charges are going. Okay, so once you find the charges, you have to make sure you have the same amount of positives and negatives. So if we take a look here at this, I have a +1 and I have a -1. Are they the same? Yes. +1, -1, oops. That's going to give me 0, which will give me a neutral charge. So the formula for a compound of lithium and chlorine combined would be, really simply, LiCl. Okay, you notice how I'm using little letters for the second letter. You can't use capitals. That would be incorrect. Okay, because the capitals mean something else. So it would just be LiCl. Okay, let's try another one. we're going to combine, make a compound between beryllium and fluorine. So if I take a look at my periodic table here, you'll see that beryllium is right here. It's number 4, and it has a +2 charge. So I'm just going to go ahead and write that there, +2 charge. Now I'm going to go ahead and find fluorine, which is over here. It's number 7, it's number 9 over here, but it's in the -1 column, so it's going to have a -1 charge. So I'm going to go ahead and write that over here, okay? So we need this to be neutral, +2 and -1. If we were going to put them together, we would end up with a +1, and we don't want that. We want this number to be 0. So what's going to happen is we need more of one of these to balance out. Do I need more positives or more negatives? Well, I have 2 positives here, and I'm just going to draw this out so you can kind of see. I have a plus and a plus, right? 2 positives, and I only have 1 negative. So I need another negative. So what I'm going to add is another fluorine ion here. Okay, the whole fluorine ion. So now I have another negative charge. Oops, sorry, I was trying to use yellow there. Okay, I have another negative charge. So I have 2 negative charges and 2 positive charges. Are those equal? Yes. So now it would be neutral. Okay, so now I can write the formula of this compound. Okay, so here's where all I have to do is I'm going to count up how many I have of each ion. Okay, so how many beryllium plus 2 ions do I have? 1. So I'm going to write B, oh sorry, I wanted to do that in regular. Okay, BE. Okay, I have 1 of them, so I don't need to put anything. And then how many fluorines do I have? Well, I have 1 fluoride ion, 2 fluorine ions. So I would put right here, I would write F, because that's my abbreviation for fluorine, and I have 2 of them. 1, 2. So I would put a 2 down here. Okay, we're going to do one more. And this time we're going to use beryllium again, but instead of combining beryllium with fluorine, this time we're going to combine it with nitrogen. So if I take a look over here at my periodic table, I need to find the charge of nitrogen. So when I look, nitrogen is a nonmetal, it's right here. Okay, it's in this -3 column. So that means that the charge of nitrogen is a -3. So I'm going to write -3 up here. Okay, now I'm only writing the charges just to help me make sure that that they're balanced, okay, that it'll end up being neutral. So right now I have a +2 and a -3, and what I'm going to do is I'm going to draw out how many pluses I have. Okay, so for beryllium I have 2 pluses, and for nitrogen I have 3 negatives. Those are obviously not equal, right? 2 and 3 are not equal. So right now, what do I need more of? If you said positives because we have less, you're correct. So I'm going to add another beryllium ion, which is still +2. Okay, so what did I add to my column over here? I have 2 more pluses here. Oh wait, what's now happened? Are we equal yet? Do we have the same amount of positives and negatives? No. So now I need more negatives. So I'm going to add another nitrogen ion. Okay, so that added 3 more negatives. Sorry guys, I was trying to just keep it the color coding. 1, 2, 3 more. Okay, do I have the same amount of positives and negatives yet? Okay, so I'm just counting these and counting these over here. No, we still don't have the same amount. What do I need more of? I need more beryllium, which is positive. So I'm going to add another beryllium ion, which gives me 2 more positives. So let's take a look here. I have 1, 2, 3, 4, 5, 6 positives. And how many negatives? 1, 2, 3, 4, 6 negatives. So are they equal now? Yes. Now I can write my formula. Okay, so now all I'm going to do is count up how many of each of the ions I have. So let's start with beryllium. So I'm going to write beryllium. I have 1 beryllium ion, 2 beryllium ions, 3. So I am going to put a 3 as my subscript. Okay, that's just telling me how many. And then I'm going to count up my nitrogen ions, which I have 1, 2. So I'm going to put N, and then I'm going to put 2 down here. So this ends up being your formula. One little last part about binary ionic compounds. When we talk about the binary ionic compounds, we're talking about things with fixed charges. So all of these columns that I marked on here are mostly fixed charges. For example, all of column 1, they all have a +1 charge. All of column 2 has a +2 charge. These have +3 charges, okay? This all has a -1 charge. This column, -2, -3. These are all fixed charges, and that's very, very important. When we start talking about these are variable charges and they can change. So we're focusing on the fixed charges. Okay. At the end of your notes, I want you to write the formulas for these 3 problems. The first one is sodium and sulfur. The second is calcium and oxygen. And the third is cesium and phosphorus. Be sure to include those when you upload your photo today, and have a great rest of your day. If you have any questions, of course, send me a message in the chat or send me an email or a remind or anything so that I can help you out.